All right, now that we've established what some of these global wind patterns should look like, and a little bit of the physics for why these wind patterns act the way that they do. Remember, it's a combination of motion of air from hot to cold combined with the rotation of the Earth that gives rise to these different cells. And so associated with these different cells, we have air that rises up from the ITCZ, the Intertropical Convergence Zone, and then terminates at 30 degrees north to create a somewhat warm, high pressure region. And then from the 30 degrees north to the equator, we have these southeast trade winds. Okay? And so associated with that then, along the coast of North America, we have a component of the wind that is easterly. So this moves off the west coast of North America. And in the southern hemisphere, it moves off in the same direction off of the west coast of South America. So when these winds are moving like this, it's called an offshore breeze. And so in both of these situations, then, we would have offshore breezes. Let's take a look at a side view of the North American coast. So we have this easterly breeze. Here's North America. And so what does this easterly breeze do? Well, this creates a void along the coast where this landmass hits the ocean. Okay, and so by pulling the ocean away from the landmass, basically driving the ocean out in this direction, this encourages cold bottom water to rise up. And so this is our normal situation. This is not El Niño yet. Okay, so this is just what we expect on the average from everything that we've learned so far about global wind patterns, is that there should be a component of this wind which goes offshore that pushes the ocean water this way and tends to drive up water from depth. And so this tends to be nutrient-rich water. Now the reason that it's nutrient-rich is that the water is colder. And water that's colder is able to float plankton better. And so plankton are the nutrients for fish, and so fish tend to survive better under these kinds of conditions. But when we get an El Niño, what will happen is that this easterly wind is overcome. And typically this may be caused by some kind of a high pressure air mass which strengthens in somewhere in the Pacific. And so that tends to push air in the opposite direction. And we should mention here that the ocean currents follow along with the wind currents. And so it's the wind currents that drive the ocean currents around the surface of the Earth. And so if you're going to start with an understanding of what's happening with ocean currents, you must first start with meteorology and look at how the air currents are pushing the water around. And so that's what's happening here then, is that this wind, which comes from this high pressure region out in the Pacific somewhere, cancels out the easterly breeze. And that pushes this warm water onto the shoreline. So in other words, the ocean temperatures rise. Now, I should mention, just as a brief side note here, that the operation of our nuclear power plant, Diablo Canyon nuclear power plant, will have the same effect on the local ocean conditions, because it dumps out something like 1 million gallons a day of warm water into the Pacific Ocean. And so at one time they were trying to show that this was affecting the population of fish that were in that vicinity of the west coast near Diablo Canyon, but weren't able to conclusively prove anything because we had an El Niño condition which was creating the same effect. And so both of those effects together probably added, but it was somewhat impossible to tell the difference between them. And so that the analysis of Diablo Canyon was interfered with by this El Niño condition. Okay, so with this warm water cap, this prevents the nutrient-rich water from coming up from below. So this is like a block here. So the nutrient-rich water can no longer come up because there's no void up here. The void was created by the easterly winds, which push the ocean water out. But now that we have these westerly, locally westerly winds pushing the warm water onto the shoreline, the cold ocean water cannot circulate. By creating a higher pressure here, this pushed the polar jet farther north. And as we saw in the last video, it's these jet streams which carry storm systems to our part of California. And so with the jet stream having moved farther north because of this chain reaction of warmer water here causing the polar jet to retreat farther north because it's warmer all the way up at this point, that then reduced rainfall. say here. We want the polar jet to move farther south. And then that causes increased rainfall. Sorry. Okay, so the net effect of this warmer air is to move the jet farther south so that that jet stream could then carry storm systems right into our part of California. Now, in contrast to that, we have La Niña. In La Niña, the westerly winds are gone. This high pressure is not there, but the easterly winds are given an extra boost. And so if we look at that same picture of North America, and then here's the ocean, we would have a stronger easterly breeze. This would create more of a void here as that warm water is moved out along the inner tropical convergence zone, moving this way even more forcefully. That draws up more cold water. And then this has the net effect of doing the opposite thing to the polar jet. What I had said before is what happens with La Niña. The polar jet tends to move farther north. And with the polar jet now farther north than normal, that means that in this part of California we have reduced rainfall because we don't have the jet stream bringing in those storm systems to our region of Southern California. And so oftentimes we'll get a flip-flop over a period of a couple of years where it goes back and forth between El Nino and La Niña. Where we get either alternatingly larger amounts of rainfall or lower rainfall. But recently, what we've discovered is that the El Nino conditions can be overwhelmed by global climate change. And so the increase in the ocean temperatures that is caused by global climate change and by the melting of the glaciers and everything else that is associated with greenhouse heating, greenhouse gas heating from carbon dioxide in the atmosphere. By increasing the temperature, this creates a situation where the El Nino effects can be overwhelmed by the global climate change. And so we're not seeing as strong a correlation between El Nino and rainier years as we used to. And this could also be associated with a general drying trend for all